Hello, welcome back to my channel. Whiteboard Economist here, bringing you another video lesson on Calculus 1. And so today we're going to go over product and quotient rule. And as you may recall from my previous videos, we already learned how to do some basic differentiation, but we're going to go over that real quick. Say you have f of x is equal to x to some sort of power, some sort of constant power. Then to take the derivative, you simply do f prime of x. You just bring a down times x to a minus 1. So for a numerical example, we'll just do f of x is equal to x to the third power. And then f prime of x is equal to 3x to 3 minus 1, 3x squared. Now this is simple enough. It gets more complicated when you have a function like this. Let's say 2x to the third times, I don't know, 4x to the 4x squared. And you want to take the derivative of this entire function. How would you do it? Well, as you can see here, these are two separate functions. And how do you take the derivative of them together? Well, for that you will need this thing called the product rule. And for the product rule, you split this function up into two separate functions. You have f of x times g of x. And as you can see here, we'll set this as g of x, we'll set this as f of x. Whichever order you set them in, it doesn't really matter. We'll just do this like this for now. But product rule states that when you have a function in this form, the derivative is the first times the derivative of the second plus the second times the derivative of the first. And so for this example, you have f of x is 2x to the third power times 4x squared. And this will be your first function, this will be your second function. So going by product rule, you have first function 2x cubed times the derivative of the second function, which is 8x, plus second function 4x squared times the derivative of the first function, which is 6x squared. And so to simplify this out, you would get what? 16x to the fourth plus 24x to the fourth. That gives you, I cannot do addition tonight for some reason. That is 0, that gives you 40. Okay, so that's 40x to the 4th power, according to product rule. So now you might be asking, well, why should I believe you? Why does product rule hold true? Why is the derivative of this function 40x to the 4th power? So let's just prove product rule real quick. This will take won't take long. So to prove product rule, let's just go with this example. Let's say x to the 6th power. Clearly, the derivative of this function is simply just 6 times x to the 5th power. But x to the 6th can also be rewritten as x to the 4th times x squared. And going by product rule, you have first times the derivative of the second plus second times the derivative of the first, which gives you 4x to the 3rd power, and that becomes 2x 5th plus 4x to the 5th. You add them together, you get 6x to the 5th power, and clearly you can see that these are the same. And thus, product rule holds true. And so, now that's all for product rule. Let's move on to quotient rule. I promise on a later video we're going to go through more examples of product rule, but today I'm sorry for moving a bit fast, but I just got to get through the material real quick. So for quotient rule, you have f of x over g of x. And you can see here that this is division, hence the name quotient rule. And it's a bit more involved than product rule, but it's not that hard either. You just need to remember this equation. You need to remember the numerator and the denominator part. The denominator part is easy. It's just the bottom function squared. Just the bottom function, not the derivative, just the bottom function itself. And for the numerator, you do the bottom function times the derivative of the top function minus the top function top function times the derivative of the bottom function. Now, a quick way to remember this is low d high minus high d low over low squared. And so let's just do a quick example of this. Let's say the function x squared plus x minus 2 all over x squared plus 3. Okay, so clearly you can see that this is a quotient, so we need to use quotient rule. And so how do you do this? You have the derivative of the, well, first let's do the denominator. You have x squared plus 3, then you just square that. Then for the numerator, you will do low d high, which is 2x plus 1, minus high d low, which is 2x. Now this is your end result here. We could simplify this out a bit more, but that's just basic algebra, and I'm going to assume that you are capable of doing that. So when we go over more examples in a future video, we'll solve this out completely, but as for today, we're just going to leave it in this form to save some time, because there's something else I want to show you. Using quotient rule, we can prove a trig function with this rule right here. Now, I know we did not go over trig functions yet. We'll go over those in a future video. So today, just take my word for this. But what I want to show you is the derivative of tangent x is equal to secant x squared. Now, like I said, we haven't learned this yet, but just take my word for it now. But tangent x is also equal to sine x over cosine x. You may recall this from your previous geometry classes. And so, what do you do with this? Well, you can do quotient rule again, and with quotient rule you have low squared, which is cosine squared x. So low d high, the derivative of sine x is cosine x. Again, just take my word for it now. Minus high d low, the derivative of cosine x is negative sine squared x. Just negative sine x. So what do you get from this? Well, if you solve this out, you get cosine squared x. The negatives cancel out, so you get sine squared x. And that's all over cosine squared x. So, well, how are these functions equivalent then? Well, if you recall from your previous classes in geometry, cosine squared x plus sine squared x is equal to 1. So effectively, this equation is equal to 1 over cosine squared x. And what is secant squared x? Well, this is also equal to secant x times secant x, which is also equal to, and since secant x is equal to 1 over cosine x, this is equal to 1 over cosine x times 1 over cosine x. And this function right here is the same as this function right here. Well, just multiply this out. And so by quotient rule, we have proved that tangent x is equal to secant x squared. And well, that's all the time we have for today, and this concludes our video of product and quotient rule. And like I said, in the future video, we'll go over more examples of these two rules, and we'll solve some problems out so you get a better idea on how these are used. But I hope this video has cleared some things up for you and that you understand this topic a bit better. And as usual, have a nice day.